Hi, welcome to my classroom, or today my classroom's in my house, so welcome to my house. Today you guys make sure that you have a notebook with you, and I also mentioned to have your reference table. So your chemistry reference table looks like this. I gave this to you the other day, and you want to turn to page 9. And on page 9, you're going to see the periodic table of elements. And specifically today I want you to pay attention to this one, lithium. It's number 3 on your reference table. Okay? So once you have that out, you should definitely pause me right now until you have that all set, and then I'm going to start again. So I asked you to look at lithium here. And remember what we said about the structure of the atom. The atom has in it protons. The protons give the atom the positive nucleus, so they're found inside the nucleus, and they're massive, remember, because the positive particles that were shot at them in the aluminum foil, or I should say the gold foil that Rutherford shot positive charges at, they bounced back, and they bounced back because they hit something real massive that was positively charged. Well, on your reference table, when you look at this number, this boldface number, this 3 stands for protons. Okay? So that 3 is representing protons. You notice the numbers underneath. There's a 2 and then there's a 1. Those represent electrons. Now, electrons, according to the Bohr model, he said that electrons were found in energy levels of energy. This first energy level is holding 2 electrons, and this also is saying that there's one more electron out in a different energy level. Total, the 2 plus the 1, and you get 3. So in lithium atom, there are 3 protons and there's 3 electrons. Now if I go up here to this number 6.941, this is an averaged number, and it's the average mass. And you see that on your reference table. Okay? So the average mass is really representing how many protons and neutrons are in the nucleus. So protons and neutrons give the atom its mass. Okay? So what we usually do is we usually take this number and we're going to round it. Okay, so we're going to round this to 7. So right now, if you look at lithium, it's got a mass of 7 and 3 protons. But I said that the protons are what gives the nucleus its mass, but guess what? There are also neutrons inside of that mass. So if I take the 3 protons away from the mass, there's going to be how many neutrons left over. So when you take 3 away from the 7, that tells me that I have 4 neutrons. So, to summarize, this atom of lithium has 3 electrons, 3 protons, and 4 neutrons. All this information I get straight from the periodic table of elements. Tomorrow in class, you're going to get an assignment that has to do with the Bohr model. And you have to take information from the Bohr model and understand about the different particles or different parts of the atom that are there based on what you see in the Bohr model. You're also going to be asked to go from the periodic table information and draw Bohr models. So there's a couple things that you need to get straight. So let's go back to your periodic table of elements. Like this on page 9 of your reference tables, and specifically we're going to go over to oxygen. Okay, so take a look at oxygen on your periodic table. I could take that information and I could change it into structures of the Bohr model that looks something like this. Now think about it. Where does 16 come from? What is the 8 telling us? And then how can I translate those two numbers into a figure like this? Okay? So, the bottom number down here is telling me that I have 8 protons. I also took that information and I put it in the nucleus of my drawing over here, say 8 protons. When you take those 8 protons away from the mass, because the rest of the mass is neutrons, what does that leave you with? Well, over here I'm saying that you should have 8 neutrons then. So in the nucleus what I've drawn here in the nucleus are 8 protons and 8 neutrons. Also, you're going to see in your reference table that below the number 8 is going to be a 2 followed by a 6. And if you look at the drawing then, it's going to be 2 electrons in this first energy level. And in this outer energy level, you're going to have 2, 4, 5, and 6 electrons. So there's 2-6 total electrons. Altogether, there's 8 electrons being shown. You think you can do that?